Hey everybody, this is Larry. This is me going over today's problem, 2707 extra characters in a string. If you see that my solution's already up, it's because I made a big boo-boo. I misread this problem for about like 16 minutes. If you 15, 16 minutes. If you want to jump ahead, this is my heads up to you to jump ahead. You don't have to. You can watch Larry suffer for 15 minutes, but yeah, just give me a heads up, and yeah, and you could kind of do that. Anyway, back to the other Larry. Boop. Hey everybody, this is Larry. This is day 2 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Let's do them all together this month. I guess starting today. Today's problem is 2707. Extra characters in the string. Just judging by the number, I feel like we've done this on a contest recently, but maybe not. I don't know. Let's see. You're given a cylinder that string S and a dictionary word dictionary. You have to break S into one or more non-overlapping substrings, such that each substring is present in the dictionary. There may be some extra characters in S that are not present in them. Return the minimum number of extra characters left over. You break up S optimally. Okay. I think this is a weird medium in the sense that s.length is really not that expensive. Oh, sorry. I don't even know. S.length is only 50, right? So you can really do like 50 cube, and which is, I guess naive is probably 50 cube, if not less. And that should be fine. So it's a little bit awkward to be honest. And I imagine. I was gonna say. If you search on YouTube for this problem, you probably actually see me do it during a contest as well, which is very recent. I'll look it up after I solve it again today, but it feels very recent. But in any case, given that you can do 50 cube, during a contest you should do 50 cube. And I'm just going to end up doing that. But the question, maybe as a upsolve, you could ask yourself, can you do a little bit better than 50? Well, even 50 square. I think the actual thing is it's 50 cube, because for each character you see if it starts with this word, so it's 50 square and it's length 50. So is there I want to say maybe if all the characters or if the length of dictionary is the same, you could do a rolling hash kind of thing to match up. Of course, you can still do a rolling hash. You could do one for each character and then do maybe 50 at a time, maybe. That ends up being n square, which is still an improvement, I suppose. I guess that's n square, which is an improvement over n cube. And I say n in a really lazy way. This is not n. Let me rephrase everything. It's not n cube, it's 50 cube and 50 square. Of course, you don't need this for this problem because it's 50. But there's n, there's L or D for dictionary, and then L for length maybe. So maybe we could define it this way instead of me being lazy and say n square or n cube or whatever, which is not quite true. I'm just being lazy because it's 2:30 a.m. I suppose. Let's say D is equal to length of dictionary, and L is equal to max of length of dictionary I for I in range, or for I, or just like max length of word for word in dictionary. Maybe that's a little bit more precise, or at least Pythonic. So something like this, right? So it's going to be n times D times L. If you kind of do a rolling hash thing, you could get it down to n times L plus D times L. Of course, D times L is the size of the input, so you can't really do faster than that. That's a lower value. Maybe you could optimize the other size of it, but or technically you could say summation of what the lengths of the characters as well. There are a couple of things you can say to it. It's I think that's all I have for this one with respect to can I do better than rolling hash? I imagine not. Or at least not without some I mean, maybe there's some crazy complex algorithm. I don't think you could use try in a very any good way. Maybe you could do suffix tree, I suppose. Actually, maybe I'm wrong on that one. You could pre-process s instead of the dictionary, and then loop over each word in the dictionary to see if if that's just how a suffix array or suffix tree lookup kind of thing. And in that case, what would that be? I mean, it's still the same as the rolling hash idea in the. Yeah, I mean, it's still going to be rolling hash because I think that may be the lower bound because at least on the d times l side, n times. Yeah, because then I guess that sounds right. Plus a very complex O of n construction, linear suffix array construction, say. Or it's n log n. I always forget. It's been a while. But yeah, I mean, I think d times l is essentially linear, so you can't really do much better than that. And on one side, of course, you can maybe optimize array the n times l side, but even then, it's hard to imagine you can because you have to. Yeah, it's hard to imagine you can. Oh, I guess technically it's not n times l. I think I just confused myself again. The suffix array solution would be n plus d times l, which I guess is probably lower bound. It's linear on both sides. So, yeah, you can do better than linear if that's the size of your input. All right. I'm not going to do that. With all that said, hopefully, if and I don't know that, so things to look up if you want to upsolve. I'm not going to do it. It is a little bit later, and also for this form unnecessary. You could do suffix array or tree array, and there's some rolling hash is probably like if you want to self-teach this, it's probably like a one lecture class kind of thing. Assuming that you have the background for it. Suffix tree array may be like a 2-3 class kind of thing to really understand a lot of the applications. Though for this problem, you probably get away with very basic applications. So anyway, that's and oh man, I just realized that my browser is looking at the wrong thing, huh? I mean, I haven't typed anything, so I guess that part is good. Sorry, friends. I mean, I didn't really type anything. I just kind of so I guess in that sense, no one missed out anything, which is good. Lucky I noticed this early. But all I wrote was I defined n, d, and l, and I just wrote down rolling hash and suffix tree, and then we just talked about it, right? So okay, let's just do the naive thing, and yeah. I mean, I imagine or uses it. Use is equal to force times s, and then for word in dictionary if okay, not distinctly, right? So how do I write this in a lazy? I mean, because I feel like Python doesn't have a like you could use regex to do a find or, but even then, I don't think it returns the index. I mean, I think the way that I would write if I'm lazy with doing n times d times l is just something like and spelling dictionary correctly, hopefully. N is equal to length of s, and this is just I don't know why I'm so sloppy. Right, if si starts with word, then now what happens? Then you could probably do like a thing replacement, but I'm just going to do something like for j in range of length of word, s or use sub I plus j is equal to true, and then that's pretty much it, I think, in concept. and then now we just return count of is that how I write it? B is equal yeah, I guess this is a weird, always awkward way to say it, right? So not B for B in used, right? Is it count or sum? I always forget. A number is required, fine. Yeah. I mean, this would be really embarrassing if I kind of mess this up, don't I? Let's take a look. Whatever. YOLO. Oh no! How does this even go on? Do I have an off by one? Ah well, I was a little bit lazy. How did I get wrong on like this 1,900 and whatever in? How are there so many other basic things? But also, how am I getting this wrong? Am I just like missed by one or something? Off by one? To be honest, I'm stumped. Do I have a typo? I don't. This is too simple to really have typos. J is 0, 0, this from I all the way to each character, right? So that seems okay. It goes. I think the starts with is only sketch, but man, I said a lot of stuff to make a silly mistake somewhere. That is awkward. Let's do this for a second. So it's saying 1, 2. This is not readable, is it? It's not helping him to debug. What was my answer? My answer is 8, where it expects 9. So what does that mean, right? That means that my solution is doing better than the expected solution, which means that there is a logical error somewhere. We're usually off by 1 or something, probably marking something as true instead of false, because yeah, because if the algorithm is, or that usually points to an implementation error at least, because if the algorithm is wrong, you can only be wrong on the suboptimal area, right? So that's basically the thing I would say. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I mean that counts, right? All right, let's see. For I. I guess this has to be done. Okay, so now it's doing MRA. This 1, 2, 3. I guess that's fine. I'm gonna just. I was being lazy. Let's actually write something a little bit better. Right? So. If it is not used, print s sub I else. This is double negative too. This is terrible. This coding at 2 a.m. is not great, I suppose. Right, so that's not right? If used for word, did I do something wrong? Why is this so wrong? I thought that after the first loop, MRA would be whatever, right? Didn't we look at that? Print word. Oh, the first one's not MR. What was I looking at? Okay, so that looks right. That looks right. Oh, MR is just the first one that copies. I see. Okay, that looks good. And that looks G. No G. Whatever this is. No good. IP. So we did better, so they think that we did better. Huh. KE, okay, we did KE, okay, fine. LPL, we did LPL, good, good. CDHX, okay. Now we have 6, 7, 8, 9, 12 characters left. I don't look at use, do I? No, that should be fine. And this does not really change that much. Okay, so XO, I expect the previous character was an X, yep. So we got rid of the O and the XO. And now we have 8 characters left. How do we, oh, and we got rid of these. I mean, am I misunderstanding the problem? Oh, I did misunderstand this problem. Wow, what am I doing? I missed the non-overlapping part, I think. That's... Wow, what am I doing today? I missed one. I must be thinking of some other problem. Sorry, friends. Sorry I make you waste 16 minutes on me solving the one problem, but at least now you know what this problem would look like if there was a naive problem. I don't know. I don't know what I'm doing. What is Larry doing? I thought it was just an optimization problem. I don't know. Wow. I missed the non-overlapping part. Even though it's in bold, this is all on me. I've been misreading a lot lately, so my apologies. All right, give me 2 seconds to reset because this is just dumb. By this, I mean me. Wow. I'm glad I didn't do that during the contest, I think. Hopefully not, anyway. So apparently, you know, this happens. Okay. So, I mean, non-overlapping, there are a couple of ways you can do. I mean, I think this is literally yesterday's problem or something like this, right? Was it yesterday's kind of... No. What was it? I mean, I guess like last week? I guess I can look at last week's problems. But I think that was like the problem last week where we have sweep line and stuff like this, right? So basically we're just trying to... Yeah, but not over. I mean, there are 2 things, right? The minimum number of extra characters left over is just the maximum number of characters that we used, right? Because it's non-overlapping. Hopefully that makes sense. Wow, that is kind of crazy, isn't it? That my silly algorithm, and one of the reasons why I didn't immediately think I didn't have the wrong answer, or I didn't misread it, is because this case is like 1800 cases in. What are they doing with the other 1600, 1700 test cases that is so useless that they can't even, I don't know, like I did it with overlap and it worked okay. This is so weird. So weird. Okay, but in any case, it is, you know, it becomes, in that world, it becomes longest path in a DAG, right? You could kind of think about each word as a possible segment on the original S, and then now you're doing a sweep from left to right, and you're just trying to get, you know, the best solution that is possible. Yeah, and you could do this in a couple of ways. Given that n is equal to 50, so I'm just going to do DP. You could also probably pre-process things and do like a sweep line as well. But the pre-process also takes n times d times l. So I don't know if it's that much. You know, you don't get that. I mean, that's going to be the restricted part anyway. So yeah, man, maybe you know, maybe I need to sleep more. Yikes. Okay, fine. Sorry, I'm just still like, wow, I spent 15 minutes wasting your time. Sorry, friends. Okay. I mean, yeah, I'm just going to do a straightforward DP and then call it a day. My apologies, friends. But yeah, so maybe something like get min. We have an index which represents the suffix of the string s that we're trying to figure out, as we said, the max number of characters used. Yeah, or I mean, we could do it either way, to be honest. At this point, I don't think it matters that much, because then now you can say, yeah, let's do let's instead of doing the transfer or inverse thing, we can just cross it, right? So basically, yeah, if index is equal to n, then we return 0. Yeah, because we're done with minimum characters. Otherwise, what are we doing? Right, we can look at each word. So word in dictionary. So let's say best is equal to get min of index plus 1. So this is this is the cost of skipping this character. If you skip this character, you're saying that this current character has 1 character left over. So this is why we're skipping it. So yeah, so then the plus 1 is the cost of skipping it, and this is actually skipping it. And then for word in dictionary, if s sub I starts with word, then here we can say, okay, let's use this word. What can we do, right? Yeah, min of best, get min, index plus length of word, and we don't have any extra spaces because we use all the word, and that's good. And that should be good. There are a couple of optimizations you can make. The first one being, doing memorization. The key thing to notice is that index can obviously only go from 0 to n, so we can memorize it, right? So let's do that first of all. Oops. Sorry, friends. This is a pretty. I mean, the other one was a standard problem too, I suppose. So I don't know. What am I doing? I don't even know how to write code anymore. Right. Right, so yeah, this will get you O of n times, O of n iteration, and this is index. This is not O of n time. I'm just confused and dumb. But yeah, so what is the complexity here, right? I'm gonna do a quick submit. All right, so during the contest I did, 1250. That's kind of a round number. I don't know. What did I do during the? So I did the same thing during the contest, basically. Yeah, I just misread this one so bad today. This was only 3-4 months ago. I was in where was I? I don't know if I did this live then, because I was in I think I was in Armenia at that time. So I don't know if I think I was probably just hiking a lot when I was in Armenia. I didn't do them live, but I don't know. This is what live looks like. I don't know, but yeah. I think one more optimization that you can do, and this is already kind of okay. What is it, 71%? Is noticing that, if word is already used or if the length of word is already done, then we don't need to do it again, right? Meaning, if I don't know, scene is equal to, I mean, you kind of trade some extra space for this. I didn't do the analysis yet. Oops. So how many? So yeah. Let me do that. So total time is you go to time per input times number of inputs, right? Number of inputs. So number of inputs, as we said, is going to be O of n. The time per input is going to be O of, for each word we use. We do a comparison, so at this index, so that's going to take O of D times L, right? This is O of D, this is O of L, and so this is O of D times L, and so total time is just going to be O of N times D times L. Yeah, and that's pretty much the idea. I mean, you can make an optimization saying that, like, for example, if you already did this calculation, you could skip this. It's a way minor thing. I don't know if it even makes sense to do, but we can play around with it. It is definitely premature if you need it. But yeah, So used that how add, right? I think length of word, right? And basically if length of word is not in used and this, so then now basically it makes it cheaper, because in theory this is more expensive than, and this operation is why you want to do something like this. Let's give it a submit. I don't know that makes that much of a difference. Apparently not. So, or even worse, the reason is because this does cost something. So it just depends on your size, or not even the size of the input, but the distribution of the inputs and what kind of input you're likely to see, right? If you have the type of input where dictionary match all the time, then you definitely want to skip this comparison if you can. But you're still going to get the same O of the big O. It's just that it depends on the cases and stuff like that. I just kind of added in there as kind of like a thought experiment, so or that you can think about things like this to kind of play around with, because the reason is that at this point, if you do it for this length, then you already kind of yeah. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I cannot read. I'll see y'all later and take care. Bye bye.